Good morning, ladies and gentlemen. In this presentation, I'll be discussing with you the basic concepts of animation types, how to implement them, and which ones you should choose to implement to provide the best user experience. For us to first understand the importance of these animations, we must first investigate what is an Android animation. According to the Android developer site, animation can be defined by one of two types of animations: the property animation or view animations. Property animations can be implemented into an application by modifying property values of an object. A developer can adjust these values within the XML files of an Android application. These properties can include color, fading in and out, or displacement of an object, creating the illusion of movement to the user. The property animation system allows you to modify certain types of animation characteristics. These property animation types include duration of the animation, like how long an animation will run for, time interpolation, which is basically known as the rate of change of animation, and also what we can think of it as is acceleration and the deceleration of the compiled animation frames. Then you have repeat and count behavior. We can think of this as the number of loops or repetitions that the animation chooses to go through. And lastly, we have the frame refresh delay. And the frame refresh delay is actually the refresh rate of the frame of an animation. And you can set it to how long it takes to render an image upon the screen. But this is also quite limited due to the computational ability and the speed that the device can handle. Here is an example of property animation provided from the Android developer site. An animation object is visualized as a box with assigned XML and property types. We can see by the blue arrow pointing to the right that this is a visual representation of the animation's object movement over the duration of 40 milliseconds. And as time goes by, these XML and property values change accordingly to suit the purpose of the animation. In this case, the animation will be visualized moving rapidly to the right of the screen. If we look towards the leftmost box, we can see the animation object is assigned a X value of 0. This X value is the horizontal layout location of the object on the screen. So when looking at the leftmost object, you can visualize it as being on the leftmost side of a screen Android application. Over the time of these 40 milliseconds, the animation object moves its horizontal location at a constant rate of 10 pixels per 10 milliseconds. The movement of this image frame is what makes up the linear movement of the property animation. So when you're looking at the property characteristics of the animation, we can see the animation has a duration of 40 milliseconds, and time interpolation is actually constant because the object is not accelerating nor decelerating. It's moving at a constant rate. So you'll see that the animation is moving at a constant rate from the left side of the screen towards 40 pixels to the right over those 40 milliseconds. The other type of animation I'll now discuss is view animation. View animation consists of two different types of animations, so that being frame animation and tween animation. A well done implemented frame animation is normally unnoticeable to the human eye because the several animation frames that are put together in played in a rapid order just display a continuous and smooth animation. For us to create a frame animation, we will require the default main activity class and multiple drawable animation frames. These frames will be compiled together to create our one working animation later on. The first step to creating the frame animation is to create a drawable XML file and create drawable items, which each frame will be compiled to create the full animation. The remaining steps will be done in the main activity class. As you can see, in the second step, we'll need to declare the image view of the application and drawable image. This should be declared globally before and outside of the onCreate method. The third step is to set up the animation frames when the activity view is loaded and is visible to the user. As you can see, we are setting up the animation view as an image view and setting the animation view as the background, as well as calling the animation drawable. And the fourth and final step is to call the frame animation to start or stop. This should be done outside of the onCreate method, as we'd like the animation to start when the user's view has fully loaded and completed. An example of frame animation could be a battery charging animation. A higher transition duration was probably needed for a frame animation of this type, just so the user can get the full user experience and understand what is happening. On the other hand, tween animation is a view animation performed by the transformation of a single frame of an image. Much like frame animation, we require the default main activity class and XML layout. However, as we do not have like the several animation frames to display, like frame animation, we can just assign one image to the image view in activity main.xml. This can be seen in the first step, as you can see, where we put in an image view which displays that singular image. In the second step, we'd like to set up the view in the onCreate method. In our case, our layout that will be used is the activity underscore main XML layout. In the third step, we need to create a new folder to store our animation transformations in. We'll call this folder anim and store it within our res folder. In addition to this, we'll create an XML file within the anim folder called slide.xml. And that's where we'll insert our transformation attributes. And as you can see from our code, our transformation will involve the adjustment of the Y from Y scale value, where it changes from 1.0 to 0.0. And in turn, this will result in a sliding up animation. So for the fourth and final step, we'll just be calling the method slide to start the animation and use the animation transformation attributes in that slide.xml, where it will then be applied to our animation frame within the animation view. So how would I implement my animation into say, my traveling app that I recently made. Well, for the navigation transition between the quiz questions and my traveling app, I think it'd be suitable to implement some type of animation, such as like a view sliding animation or a fade out and in animation. Because as you transition and navigate between questions in the traveling quiz, it doesn't really indicate that it doesn't really have a smooth transition between quiz questions, and I believe implementing an animation like that would actually improve the user experience and help the user actually understand and feel a bit more comfortable answering that quiz. So, what type of animations should you use? Should you use property animation or view animation? Well, it's all dependent on the context of the application and whether using one type of animation is more advantageous than the other. So, basically, from all of the discussion and researching from property animations, we can actually observe that property animations is actually easy to implement and customizable, because it's just adding those image property values. Because property animation doesn't require rendered frames, it can also be less computationally expensive, making it good for the development of older devices, but also useful for simple animations. The disadvantages, I guess, of property animations is that it also lacks a bit of creativity and diversity, and it's limited to the property attributes modifications, basically. It's only limited to what you can actually change in those property attributes. Unlike property animations, view animations can create a deeper and more complex animation that is quite good to have a good connection with the user and keep them involved and captivated, should I say. It's mainly this captivation normally comes from the animation image frames that are implemented into it. And in my opinion, I would use property animation for more simpler things. So property animation I would use for things such as buttons, navigation, very small user experience, things that improve the user experience. Whereas something that I'd really want to connect and captivate the user, I'd actually implement a view animation, such as a video cutscene or logo animation, to keep them involved and try to amaze them with the application that you're presenting to them. You want to keep them captivated and you want them to keep coming back. Well, in conclusion, there's two main types of animations in Android application development, and that's been property animations and view animations. During this presentation, I've explained the different uses of these types of animations and the characteristic types which make it up. I've also discussed scenarios where one type of animation may be more advantageous compared to the other, just because of the context which the application is built on, and of course of the user design of the application and how it suits it. Android animation isn't really necessary to be implemented into an application. Like, you don't really need it to actually create your own app and let a user use it. But when it's used, it can be very powerful and it can convey a lot of emotions and communicate ideas to the user visually, and it can be used quite well when it's implemented properly. Thank you for listening to my presentation, and I hope you learned some things about animation and its importance with Android applications. Thank you.